Assalamualaikum warahmatullahi wabarakatuh and good day everyone. We are group 2 from AS1202H. This is our presentation video assignment for MAT 183. Before we dive into this video, let me introduce our group members. The first member is Nur Alia Balkis binti Muhammad Faizal, and the second one is me myself, Muhammad Amar Hazim bin Azmi, and the last one is Nur Zakirah Alia binti Muhammad Nazri. Without wasting more time, let's begin with question 1, which asks us to explain the meaning of differentiation and the techniques used. Differentiation is a process of finding the derivative of a function. It measures how a function changes as its input changes. In simpler terms, it gives us the rate of change or the slope of a function at a particular point. The main techniques of differentiation include: the first one is power rule. The formula for power rule is: if y equal to x to the power of n, then dy over dx equal to nx to the power of n minus 1. Use the power rule whenever you're differentiating with a term with x raised to a power either positive, negative, or fractional. The second one is product rule. The formula for product rule is: if y equal to u dot v, then dy over dx equal to u prime v plus uv prime. Use the product rule when two functions are multiplied together. The third one is quotient rule. The formula for quotient rule is: if y equal to u over v, then dy over dx equal to v u prime minus uv prime over v squared. Use this one when function is divided by another. The fourth one is chain rule. The formula for chain rule is: if y equal to fgx, then dy over dx equal to f prime gx dot z prime x. Use the chain rule for composite function where one function is inside another. And the last one is implicit differentiation. Use this when equation involve both x and y and it's hard or impossible to solve for y explicitly.
Hello everyone, my name is Nur Alia Balkis binti Muhammad Faizal. So, let's move on to the question number 2. Find dy over dx for the following function. For question 2a, the problem starts with the function y equal to ln x sine 2x. To find its derivative dy over dx, we use the chain rule, which gives dy over dx equal to 1 over x sine 2x times d over dx x sine 2x. To differentiate x sine 2x, we apply the product rule. For the u equal to x, u prime equal to 1, v equal to sine 2x, and the v prime equal to 2 cos 2x. Using the product rule formula, dy over dx equal to uv prime plus vu prime. So we get dy over dx equal to x times 2 cos 2x plus sin 2x times 1 equal to 2x cos 2x plus sin 2x. Substituting this back, we get dy over dx equal to 1 over x sin 2x times 2x cos 2x plus sin 2x. So for the final answer, we get 2x cos 2x plus sin 2x over x sin 2x. Alright everyone, next question 2b. Y equal to secant x plus 1 over 1 minus x squared. To find dy over dx, we start with the chain rule. Since we have a secant function, the derivative of secant u is secant u tangent u times the derivative of u, where u equal to x plus 1 over 1 minus x squared. So, dy over dx equal to secant x plus 1 over 1 minus x squared tangent x plus 1 over 1 minus x squared times du over dx x plus 1 over 1 minus x squared. Using the quotient rule, u equal to x plus 1 with u prime equal to 1 and v equal to 1 minus x squared with v prime equal to negative 2x. The quotient rule says vu prime minus uv prime over v squared. So we get 1 minus x squared times 1 minus x plus 1 times negative 2x over 1 minus x squared. Simplifying the numerator, 1 minus x squared plus 2x squared plus 2x over 1 minus x squared equal to x squared plus 2x plus 1 over 1 minus x squared, which we can rewrite as x plus 1 squared over 1 minus x squared. So the derivative becomes x plus 1 squared over 1 minus x squared. Putting it all together, dy over dx equal to secant x plus 1 over 1 minus x squared tangent x plus 1 over 1 minus x squared times x plus 1 squared over 1 minus x squared. That's our final answer.
Hi, it's Hazim again. For question 3, the given question is 3 ln x squared y minus the square root of 2x plus y squared equal to 2. Find the dy over dx by using implicit differentiation. First, we divide the equation to 3 parts, which is part A, B, and C. Part A is 3 ln x squared y, and part B is the square root of 2x plus y squared, and part C is 2. And then we determine the product rules for part A, which is u equal to x squared, u prime equal to 2x, v equal to y, and v prime equal to dy over dx. And then we differentiate part A, which is 3 ln x squared y to a prime equal to 3 in bracket 2 over x plus 1 over y dot dy over dx. After we differentiate part B as well, we get in bracket 1 over 2 square root of 2x plus y squared multiplied by 2 plus 2y multiplied by dy over dx. Next, we combine both derivatives and differentiating both sides of the equation, and then we isolate dy over dx by simplifying and rearranging terms. After that, bring all the dy over dx terms to one side and the remaining terms to the other one. We factor out dy over dx and finally solve for it. And then we get the final answer is dy over dx equal to 1 over square root of 2x plus y squared minus 6 over x over in bracket 3 over y minus y over square root of 2x plus y squared. So, this final expression gives the value of dy over dx in terms of both x and y using implicit differentiation.
Assalamualaikum and hi, I'm Nuzakira Alia binti Ahmad Nazri. We are given a function fu equal to 8 over u cube plus ln 2u minus 3, and we asked to estimate the value of f 2.01 using differential. Step 1, we have to use the formula for differential. We are going to use the differential approximation formula, which is fu plus delta u, or fu plus f prime u multiplying delta u. Let's choose u equal to 2 because it's close to 2.01, and delta u equal to 2.01 minus 2, which is 0.01. Step 2, we have to find fu at u equal to 2. f2 equal to 8 over 2 cube plus ln 2 multiplied 2 minus 3 equal to 8 over 8 plus ln 1. And we got 1 plus 0 equal to 1. So, f2 equal to 1. Next, we have to differentiate fu. fu equal to 8 over u cube plus ln 2u minus 3. Differentiate each part. The derivative of 8 over u cube equal to 8u the power of minus 3 is d per du 8u the power of minus 3 equal to minus 24 u the power of minus 4. The derivative of ln 2u minus 3 is d per du ln 2u minus 3 equal to 2 over 2u minus 3. So, f prime u equal to minus 24 u the power of minus 4 plus 2 over 2u minus 3. For the step 4, we have to evaluate f prime u at u equal to 2. F prime 2 equal to minus 24 multiplied 2 the power of minus 4 plus 2 over 2 multiplied 2 minus 3. And we got minus 24 multiplies 1 over 6 plus 2 over 1 equal to minus 1.5 plus 2, and we got 0.5. And for the last step, we have to estimate f2.01. Now apply the differential formula. f2.01 equal to f2 plus f prime 2 multiply delta u equal to 1 plus 0.5 multiply 0.01, and the final answer we got 1 plus 0.005, which is 1.005, and we got f2.01 equal to 1.005.
In conclusion, differentiation is a key concept in calculus that helps us determine the rate at which a quantity changes. It is widely used in mathematics to analyze the behavior of functions. To find derivatives, several techniques are used depending on the form of the function. Number 1, power rule for basic polynomials. Number 2, product rule for the product of two functions. Number 3, quotient rule for the division of two functions. Number 4, chain rule for composite functions. And number 5, implicit differentiation for equation not explicitly solved for one variable. In practice, many problems require a combination of these techniques to correctly compute derivative. Mastery of this rule allows us to handle more complex functions and apply calculus effectively in real-world problem solving. That's all from us. Thank you.